Hello everyone, good afternoon. Dear authors and invited guests, welcome to technical session 570. Myself, Tanish Virmani, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you all to the International Conference on Technological Intelligence and Business Strategies, TIPS 26, Manila, Philippines. This conference is being organized in a hybrid mode. The physical event was held on 22nd June, Manila, Philippines, and the virtual event is being held through Zoom from 23rd to 24th June. I hope you will all enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have total 8 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for the question and answer. After 10 minutes, I will raise a gentle reminder for the same. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or update, then you can write us to in the chat box. Just before the session, I'd like to introduce you to the chair for this session, Dr. Chaya Jadhav. Yeah, Dr. Chaya Jadhav is a professor and HOD at Dr. D.Y. Patil Institute of Technology, Pune, India, with 30 plus years of teaching experience. Her expertise include medical image processing and machine learning. With 25 plus patents, publications, and 5 copyrights, she is a PhD guide at SPPU Pune and actively serves as PG teacher, chairman, and paper setter with memberships in ISTE, CSI, ACM, IEEE, and IAANG. Ma'am, could we have some words from you?
Yes, sir. Am I audible?
Yes, you're audible.
Yes. Good afternoon, all of you.
Good afternoon po.
Good afternoon. Sir, have you given any instructions regarding this presentations and timing?
Yeah, 12 minutes for the presentation, ma'am, and 3 minutes for the question and answer.
Okay. So I will give concluding remarks. Let us start the session.
Sure.
Okay.
We'd like to call the first presenter, John, for the paper title An Android application for pothole detection and severity analysis using sensor fusion and deep learning. Yeah. You may start your screen share.
Good afternoon. Am I audible?
Yes, you're audible.
Audible.
Thank you so much. Allow me to share my screen. So I hope you can see it right now.
Yeah, it's visible. You can start.
All right. So good afternoon, everyone. And thank you for being here today. So I'm here to present this research conducted with Associate Professor Jaime M. Samaniego entitled An Android Application for Pothole Detection and Severity Analysis using Sensor Fusion and Deep Learning. So potholes are a big problem for road safety. They cause damage for vehicles, create traffic jams, and lead to expensive repairs. Now, as the World Health Organization, it says that by 2030, the road traffic injuries could be the 7th leading cause of death. And this shows that we urgently need better infrastructure to prevent accidents and keep road users safe. So road safety is part of the United Nations Sustainable Development Goals, specifically 11.2, which focuses on providing safe, affordable, and sustainable transport for everyone. Here in the Philippines, the current methods for detecting potholes are manual inspections and citizen reporting, and these are slow and efficient. Now, to address this, the Department of Public Works and Highways issued an order in 2022 about the repairs that requires them to repair it within 3 days. However, with the large road network in the Philippines and with the limited resources, manual methods are still not enough. Now, in addition to that, the Philippine Road Safety Action Plan, this is an action plans of the DPWH or the Land Transportation Office that aims to reduce road fatalities by 35% by 2028 by emphasizing road safety audits, regular assessment, and prioritization of repair and projects. Now, as mentioned in the study of the Kanay, they highlighted that there is a need to modernize the road monitoring in the Philippines to keep up with the global advancement. With the automated pothole detection as part of the automation, there are three methods. So one is the vibration-based methods, the 3D reconstruction, the vision-based methods. But in this study, we only cover vibration-based and vision-based for the reason that 3D reconstruction is highly expensive. And in addition, since smartphone sensors work well for detection, and based from the study of Kim et al., so deep learning can enable real-time detection on mobile devices, as well as the participatory sensing, where users share data via their phones to speed up the maintenance. So adapting to these technologies to the Philippines is crucial due to the lack of established platforms. So we need to adapt to these technologies to fit local condition. And to address these, we propose a low-cost, or the Kanay et al. Proposed that we need a low-cost automated detection system using modern technology to make assessment faster and efficient. So in this study, several YOLO versions were utilized. So these architectures are YOLO version 5, version 8, 11, and 26. And these are all YOLO versions from Ultralytics. So we cover the N and S variants. So both the nano and the small variants of YOLO. So it is the models were trained using the Ultralytics, and to measure its performance, three metrics were used. We have the precision, the recall, and the mean average precision. So for the data sources, the dataset used in the study consists of 9,253 road surface images collected from publicly available pothole datasets. And in addition, we supplemented manually gathered road images. So to ensure proper model development and evaluation, 70% was divided, 70% were allocated for the training set, the 20% for the validation set, and the 10% is reserved for the testing set. These are some of the pictures with no potholes, road conditions with potholes and pavement conditions to improve diversity, dataset diversity particularly. These are captured here in the Philippines. Now, all the images were manually annotated using RoboFlow annotation tools with the assistance of SAM3 or the Segment Anything Model 3 by Meta. So that is for the improved annotation, efficiency, and accuracy. So out of the 9,253 images, which are all JPG or JPEG images, 8,236 were labeled images and 1,017 were unlabeled images. So out of 9,253, we have 16,123 total annotations with an average of 1.74 potholes per image composed of mixed and single potholes. So several data augmentation techniques were utilized, such as the HSB adjustment, the scaling, translation, horizontal flipping, and mosaic augmentation. Now, the dataset images has a mean width and height of 1,254.4 times 834.3 with a file size distribution of less than or equal to 341.8 KB, which covers 95% of the dataset, and greater than 341.8 KB to approximately 1 MB to 5% of the total dataset. As you can see in the annotation locations, majority of the pothole is located in the middle or in the center of each images. So we have here 180.9 pixel by 120.7 pixel as the mean width and height of the bounding box dimensions. And for the histogram or the object count by image, there are a total of 7,536 images, which covers the 91 or roughly 92% of the total images with 1 to 2 annotations per image. So for the training of this model, we utilize Ultralytics platform, particularly with the use of GVU, the NVIDIA RTX A5000. So next we have here currently presenting the table, the performance comparison of the evaluated YOLO models using the mean average precision, the precision recall, model size, and the parameter. And among the evaluated model, we can see here that YOLO version 11, the small variant, it achieved the evaluated performance of map at 50 value of 85.3% and a map at 50 to 95 value of 54.2%. So there is a consistent trend observed in this illustration. And as we can see here, the variant S or the small variants that's colored orange generally achieve slightly higher detection in terms of its performance compared to its nano counterparts, which are colored blue, except for version 8 of YOLO and version 5. Now, for this one, we can see here the different version, particularly basing from map at 50 to 95. So this figure highlights the superiority or the superior performance of YOLO 11S, which achieved the highest detection accuracy among all the evaluated models. Now, for the trade-off for the accuracy efficiency, for what model will be implemented or deployed in the mobile application. So we can see here in the figure that models maintained a compact model sizes approximately 5 to 6 MB while still achieving a competitive map at 50 to 95 values. So as we can see here, the small variants or the S variants, the colored orange, so it exhibited larger model sizes compared to the nano variants. And in terms of performance, we can see here that the YOLO version 26N achieved less PyTorch model size with an increase with a higher accuracy compared with the other. So with this trade-off with accuracy and efficiency, particularly with the map at 50 to 95 plus the model size, so we decided to deploy or implement the YOLO 26N for the mobile application. So for the confusion matrix, we have 82.7. So this is the normalized confusion matrix that approximately 83% were instances were correctly classified as pathole. 17% were classified as non-pathholes. So we also have here the validation loss curves for the box loss, classification loss, and the distribution focal loss. Now for the
Excuse me,
sensor-based
sir. This is just a dental reminder that 10 minutes of the presentation up. You can conclude in a minute or two.
All right, thank you, sir. So for the sensor-based pathole detection, what we have here right now are the smartphone sensors and acquisitions. So in this pipeline, the smartphone sensors such as the accelerometer, gyroscope, magnetometer, gravity, and GPS were used for the sensor-based pothole detections. So to separate the acceleration from the vehicle motion, we use sensor fusion filters such as the Madgwick sensor fusion filter. So orientation estimation were also utilized. So for the accelerometer, we separate the gravity and the vehicle motion. So this is in cooperation with the vision-based. So once the extracted key signals were extracted from the sensor base, it is added or combined with the vision-based. Now for the severity classification, so we set a confidence score to each detection. So only detections with a score above the threshold are considered valid, while the highest confidence score for PRIM is used to classify pothole as severe, minor, and moderate. So these are the mobile application implementation. So the table summarizes the application using the Xiaomi Redmi Note 11S in an urban and residential network. So the Android application was tested among 4 road segments covering a total of 18.97 kilometers. So since the testing was performed using a single smartphone, so impact of the hardware variability, let's say the camera characteristics was not evaluated and remain a subject for future work. So for there are false detections. So false detections corresponds here as lane markings, the shadows, drainage structures, debris, and other surface irregularities. And these are all based from DPWH Bureau of Maintenance Training and Workshop to be considered as pathole. So these are instance of the mobile application. So in summary, so an Android-based pothole detection and severity analysis system were developed. So an evaluation of YOLO models for mobile deployment. We have YOLO version 11 is as the highest detection performance, but the YOLO 26N have the balance of accuracy and efficiency, particularly for the model size and the map at 5295. So the application successfully performed real-time pothole detection. We have the GPS mapping and severity analysis by just simply using the sensors and the vehicle traversal. So overall, the finding demonstrate a potential smartphone-based road condition monitoring using a lightweight deep learning model. So with that, that will be the end of our presentation, and thank you po for your attention.
Thank you, John, for a nice presentation. Am I audible?
Yes, ma'am.
Yes. Nice presentation. Just one query. Have you considered the highway road that where heavy traffic is going on, or have you considered the roads which are within the city and the national highways like that? Have you considered that?
Yes, ma'am. Actually, this image, I don't see, I don't know if you can see the cursor, but this is one of the national highways here in the Philippines, the Maharlika Highway.
Okay. Okay. And the condition of road during all the seasons, that means it is a rainy season. Have you considered that also? The
Current
pictures.
In the conduct of this study, in the training data set, there are inclusion of the data set or the road condition during the rainy and both the sunny condition here in the Philippines. But since
Okay.
the conduct of the study occur during the sunny season, so that's why we do not have images
Rainy.
here during the rainy season, ma'am.
Yes. Okay. These are the real images, or have you taken from which database these images?
You're on mute. You're on mute.
I'm sorry for that. Okay, actually, these images are the actual detections, but this particularly focuses on the false positives. But what we have here, ayan. So this one is an actual test or of
Okay.
road condition here in the Philippines.
Okay. This is a real database, real time
Actual the
database.
actual data, ma'am. Yes, from the database.
Yes. Okay. Thank you.
Thank you, Doc.
Yeah, thank you for the presentation. The next presenter I would like to call is Nu Khang for the paper title An Interpretable Hybrid Deep Learning Framework for Cost-Effective Water Quality Classification in Aquaculture. Yeah, you may start sharing a screen.
Let me share this PPT. Good afternoon, everyone. My name is Nu Yen Khai from Nepal State Polytechnic University in Myanmar. And today I would like to present an interpretable hybrid deep learning framework for cost-effective water quality classification in agriculture. They are the outline of my presentation. Let me begin with the assessment theory. Water quality dataset aim to classify water quality while reducing the number of sensors required for monitoring. First, random forest and XGBoost were used to select the more important feature, and then SVM and STM were used for classification. The full hybrid model was just using 10, 7, and 5 slatted feature. And the results show the HCV LSTM and random forest and STM was at least 96.05%. Finally, such analysis was used to explain which water quality parameter contribute most to the prediction. Overall, the proposed framework reduced sensor requirement while maintaining high accuracy. Now I will introduce water quality is of most important factor affecting fish quality and aquaculture productivity. However, monitoring multiple water quality parameters require many sensors leading to high cost and system complexity. Furthermore, a traditional approach may not effectively capture the nonlinear relationship among these parameters. Therefore, this theory proposes an accurate cost-effective water quality classification framework and user analysis to improve model interpretability. Let us first review this paper. This slide presents several related review on water quality monitoring and classification. Although previous theory have been applied machine learning, deep learning, and IoT technique, limitations still exist in feature reduction, model interpretability, and communication network. Based on this paper, two major research gaps are identified: limited integration of feature selection, hybrid model, and explainable AI. The challenge of reducing sensor requirement. Therefore, this research proposes a hybrid random forest, HCV, and SVM amnesty framework with analysis. Now I will describe the data sets used in this theory. We are in this theory, the water quality data set is the data sets contain 40,300 consists and with 40 water quality parameter and 1 output label. Water input feature are temperature, WD, TO, and salt on. Target paper is water quality classification. Water classification has 3 categories. First, excellent, class 0, which have 40,000 sample and good class 1 is 40,000 sample and poor class 2 is 50,000 sample. Next to that, proposed framework methodology. This methodology consists of 6 main strategies. First, the water quality data sets records and pre-process. Next, feature selection, web platform using random forest and HCV to identify the most important parameter. The selected feature was then used to develop SVM and STM-based classification model. And model training. Model training is data set is used 80% training and 20% testing. And then evaluation metrics is used. Next, I will present the selected feature. Feature selection. Feature selection in its platform using random forest and HCV and STM. The objective is to identify more important water quality parameters and reduce input dynamically. HCV use various button to rank feature important, while random forest use as a mere decision tree to evaluate the contribution of each feature. Based on the importance, the top rank feature are selected and used in the classification stage. I will present the selected feature. This table shows the feature of important ranking order from HCV and random forest. I selected the more important feature out of the 40 based on their category important scope. Move to the next slide. After feature selection, the selected feature was used to input or to SVM and STM classifier. SVM is applying to classify water quality into excellent, good, and poor category, while STM is used to learn complex feature relationships and improve classification performance. The performance is more combo using compared using different feature selected by random forest and HCV. Next, I will present the evaluation metric. The performance of the proposed model was evaluated using accuracy, precision, record, and S1 score. The method provides comprehensive assessment of classification performance and were used to compare different hybrid models and features later. I will present the experimental results. This table shows that best accuracy of 96.05 was achieved by HCU LSTM and random forest MSTM using 10 feature selected. We observed that MSTM-based model consistently performed better than SPM model. Even when the number of features was reduced, the classification performance remained relatively among that so that random forest MSTM is highest accuracy in all features. Move to the next slide. The figure shows the short symbol blocks used to interpret the model prediction. Symbol is a powerful visualization tool that displays both the important feature and the impact of each feature on machine learning model prediction. Move to the next slide. This is a short summary plus this summary plus was pointers to improve model interpretability as shown in the figure. The source audition had the higher size value indicate the sunlight influence on water quality classification, stability, and BOT are high important, followed by H2S and nitrate. These results confirm that a small number of key parameters can effectively present overall water quality. Sporting got affected sensor deployment in system. Move to the next slide. In my conclusion, the proposed hybrid framework successfully accurate and interpretable water quality classification are the best model HCU LSTM and random forest MSTM achieve 96.05. Such analysis is the more important water quality parameter and enabling sensor reduction and cost-effective monitoring. Future work will focus on real-time IoT deployments, larger data sets, and transparent technique. Move to the next slide. Thank you for your attention.
Nice presentation. No questions.
Thank you for the presentation. Yeah. The next presenter I would like to call is Mahi Shah for the paper titled Design and Feasibility Evaluation of a Low-Cost P300 based Brain-Computer Interface for Communication in Pediatric Cerebral Palsy.
Good morning.
You can start your screen share.
Before I start, I want to say something. I have this appliance in my mouth. That is why I won't be able to pronounce a few words very clearly, and I'm very sorry about that.
Okay.
I got into some accident because of which this has happened.
Okay, no issue. You can start.
Okay, so good morning, everyone. Before I start, I want you guys to imagine something. Let's just say you guys are 8 years old and you want to say something or you want to convey something, but you just can't do it. And this is not a hypothetical situation. It is the reality of so many people suffering from cerebral palsy. It is a neurological disorder. My name is Mahi Amit Saha. I am a student studying in PSRA Pune. And so what is cerebral palsy? It is a neurological disorder which affects movement, but not the mind. But a lot of people don't know this, that it does not affect the mind. The children, they can think very clearly, they can understand everything, but they just cannot convey it. And it affects up to 2 to 3 people, children for every 1,000 that are born globally. 70% of these children, they struggle with communication, like with the ones who have cerebral palsy. So to avoid this or to find solution for this, brain-computer interfaces were invented. What are BCIs? They detect neural signals and they translate them into digital commands, which offers a better pathway for communication. Now, what all of this does is, there are many different devices and signal detection techniques that were invented as well. Now, the main question that my paper asks is, what if we could let the brain speak directly, bypassing the body entirely without paying attention to the body? So, according to the literature survey, in so many years, a lot of things have been developed, and we have come up with a lot of things as well. So, at first, Walpole, he invented BCIs. He developed the first P300 speller. What is P300 speller? It is a technique in which, when a children stares at a screen for a longer amount of time, for more than 300 milliseconds, the brain passes a signal. So, for example, there are letters going around in the screen, and if I'm staring at C for longer than 300 milliseconds, a signal is being passed. So, that is what P300 does. The children do not have to think a lot. It is naturally done through the brain. So, they don't have to think a lot. They don't have to put a lot of pressure on their head. They don't have to do anything. It is natural. So that was one of the best inventions for this kind of diseases. So after that, Sellers and Donkin, they used P300 spellers along with BCIs, and they achieved up to 90% accuracy in ALS users. After that, different separate studies were conducted in cerebral palsy. So we discovered that a lot of them were adult focused, and only 70% of children had a lot of problems with communicating. But we also discovered that BCIs as devices, they can be used for children as well. And to improve engagement, since children, they cannot pay attention at a single thing for more than a particular amount of time, to keep them engaged, we introduce gamified interfaces. Those were easy to understand and easy to look at. After that, now from all of this, the main problem was the cost. So it was not affordable. The main research gap was BCIs were proven in adults. Children could use them, but affordable and child-centric solution wasn't developed yet. And low cost is very important, because a lot of families, a lot of people cannot really afford all of these. So again, the three main problems, like three reasons that BCI hasn't reached children yet, were the cost barrier, the design mismatch, and the signal challenges. And all of them are interconnected. Cost, because they cost from 8 to 40 lakhs for clinical systems, and setting up of all of this is very difficult. Design, they're built for adults. So adults can still try to pay attention, but for children, it gets very difficult. And third one is signal. So kids are fidgeting all the time, they're moving here and there. So the signals that are generated are usually very noisy. So these are the three main problems that we faced. And after reviewing, on the second question that we had to answer was, which of the BCI paradigms was the best to use? There were 4 different BCI paradigms: P300, motor imagery, SSVEP, and hybrid. Now, motor imagery, it needed a lot of training, like weeks and weeks of training. SSVEP, it was fast, minimal training, but it required very good vision, and it was for speed based. And not hybrid, it was reliable, but it was very complex because there were a lot of calibrations that were needed. And PT100, it was the only solution that we could come up with in all of this, because it was natural, not a lot of attention was needed, communication was slower, the accuracy had already been proven to up to 90%, so it was the best thing we could use. So what I went after, or the one question that I wanted to solve, was this: how to introduce it for children, how to make it low cost. This is the proposed methodology I came up with. So the first step would be, it is a 7-step methodology framework. The first step would be EEG acquisition. So what is EEG acquisition? It is when brain signals are captured through the headset. Then the pre-processing of the signals is done. Just as we mentioned earlier, there are a lot of noise when it comes to signals generated by a child's brain. So to filter all of that, feature extraction is also done. That is done using XDON. So P300 speller as a instrument, it needs signals from 300 milliseconds to 600 milliseconds only, and XDON spatial filter does that. then it is classified based on low latency, and LDA is used so that it can be upgraded to EEG-net. And then decision logic, now a lot of signals are generated by brain, right? So we cannot rely on one particular electrode or one particular signal. So all of them are combined, and decision is made on the basis of all of them. So the average is taken out. And the last one was user interface. Now, the system that or the methodology that I am proposing, it is a very basic one for yes or no. So, for example, if a child sees, "Do you want food?" all the child has to do is stare at yes, and the people or the family would know that the child wants food. So that is the main basic system that I was trying to propose, and I wanted to make it gamified so that they can pay more attention to it. And the most important part of all of this is feedback and calibration. So it is a closed loop mechanism. What that means is, after every run of the whole methodology, a feedback will be sent back to the system to let them know what is wrong or what can be improved or what can be changed. So that is what one of my most important part of the whole system was. Now, in all of this, even right now, why are we even going for this when it is costing 35 to 70,000? Because if we think about it, it is the same outcome as a very advanced clinical grade BCI, but it is much cheaper. So the clinical grade, it costs 8 to 40 lakhs, which is, and plus the accessibility is very low because people who live in small families or in any, even common people like us, we cannot afford something like that. It is highly unaccessible for us. So, and even the research lab one, again, 4 to 12 lakhs. For that also, accessibility is super low. And there is emotive and news, but their accuracy wasn't good enough. That's why we couldn't go for that. So the proposed system, the one with OpenPCI, using Raspberry Pi for storage, and tablet, basic tablet, we our approximate cost was rounded up to 35,000 to 70,000. Now I know the question will come, ki even this is very expensive, but if you think about it, it is just a fraction of the price that you otherwise would have to pay, and the accessibility is very high. It can be installed in houses, in NGOs. So what can be done is, NGOs can take the systems. NGOs can install these systems in their environment, which can be accessible to other people for a much lower cost. So if people contribute towards this, it could actually make a lot of sense. But this was a conceptual framework. I tried to run it on a public data set, and I have gotten the accuracy of 62.5%, which right now seems to be very low. But we will have to work more on the data set. The main problem in all of this is that data set is not available. So accuracy is very difficult to define in a much clearer way. And these are the things I used while doing this. There was a classifier, LDA classifier. We used 68 EEG runners. There were 320 trials, and the classification accuracy was up to 62.5%. And ITR is information the amount of time it takes for the information to pass from the electrodes to the screen or to the system was 11.4 bits per minute. It followed a 7-stage architecture end to end. There was 80-20 chain variation split. ITR was calculated using BCI, and results were confirmed the pipeline that it can decode EEG responses using lightweight ML also. This is a confusion matrix that I got for the LDA classifier. Now, talking about the future scope, I have uh, I have already performed it for a publicly available data set, but the next step would be actually using it for CP cohorts or actual CP patients. Then user experience, we have to involve therapists, caregivers, and children, because a system should not be built for them, it should be built with them. That is a system that will actually take us somewhere. And we should improve the robustness to noisy EEG signals in real world environments. And transfer learning could also be used, because so that the system won't have to learn again with a new child, it shouldn't have to start from zero with every new patient. So to conclude, we have discovered that 70% of TB children cannot communicate, and it is not because of their mind, but because of their body. And existing BCIs are proven, but are inaccessible. So our main question that we wanted to solve in this paper was, what if we could let the brain speak directly? And what we did was, we reviewed BCI literature, we compared all the major paradigms, we designed the 7 stage framework, and we got the cost from 35,000 to 7,000 only. And we also conducted offline validation, where LD achieved 62.5% accuracy and 11.44 bits per minute ITR. So what this means, a child-centered, affordable foundation of a BCI communication has been developed. It is developed to bridge the gap between what a science can do and what children with CP actually need. So the goal in all of this is very simple: to give every child the ability to communicate, regardless of the body can or cannot do. These are the references that I used, and there are a lot of more in my actual paper. Thank you.
Nice presentation, Mahi. Are you implementing these things to NGO, or that will be a individual can be taken?
So my first step will be NGOs, because it is very difficult for people to afford all of this. And my main, obviously, it is in my title, like the main motive is low cost. So I would like to start with NGOs, and I would definitely want to expand it to individuals as well, because that is the whole point. It should be accessible for children in their own houses.
Okay, what will be the cost right now? Currently, is it available such things?
Yes, ma'am. So all of these are available they're available as clinical systems. So there are
Clinical.
the research lab and everything. All of that exists, but something like this does not exist yet.
Okay. Have you tested for this?
Yes, ma'am. I have not actually, because the data set and finding patient is very difficult over here. Plus the resources, they're not enough over here. But I have tested it on a ML model. So the
Okay.
pipeline that I designed, I try to test that on publicly available data set.
Okay, which data set you are used?
Ma'am, I have put it in the references. It was P300 data set. It is available publicly online on Kaggle also.
Okay. Nice. Again, you have to keep the information of that patient again secretly if you're testing like
Yes,
that.
ma'am. There are a
Yes,
lot of security concerns.
yes,
There are a lot of privacy concerns. And
yes,
keeping all of this in mind, actually implementing something like this will be a very huge boom to this
yes,
industry. But it is, at the same time, it is very difficult to implement something like this. But I will be working on it.
yes. Definitely. This is a very nice and social work you are doing. Keep it up. Thank
Thank
you.
you, ma'am. Sorry for the inconvenience.
No, no, no. It's okay. You
Thank,
are clearly audible.
thank you, ma'am.
Yes.
Thank you for the presentation. I would like to call the next presenter, Geetanjali Kature, for the paper title Edge-Based Adaptive Bearing Fault Diagnosis using GhostNet XG Boost and LSTM autoencoders with drift detection. Yes, you may start your screen.
Yes. Is my screen visible?
Yes,
Yes,
yes.
it will be.
Geetanjali. Clear.
Mm. So, good afternoon, everyone. Here in India, it's afternoon. So, my name is Gitanjali Katore, and I am a student from COEP College of Engineering, Pune, from India, and I am presenting the presentation on age-based adaptive bearing fault diagnosis using GhostNet, XGBoost, and LSTM auto encoder with drip detection. The why it is age-based adaptive. It is age-based because it can deploy on edge devices, and with drip detection means when any drift comes in picture, means from in the bearing dataset, then it can detect the drift and we can improve our models. So get started. So for the just a minute. So mm, mm, when bearing faults happen in motor. That is the we know that in industry, when in industry that is electric motors are available, and when electric motors comes in picture, there are bearings there. So in 41 to 50% of motor faults are occur due to of the bearing fault. So just to reduce that percentage of fault, we chooses that bearing fault detection, which is having the accuracy of our model is up to 98 percentage. And there are so many models which are present to detection for the bearing faults, but all are required a high memory, and that is not edge deployable. They require also high GPU and high memory storage, so that are not deployable on edge devices. So this model is a edge edge deployable model which can be deployed on a edge device. Mm, so research gap is that model is not available for the edge deployable model, and which also shows the drift detection. Means when drift comes in picture, models are not able to detect that drift and increase and adapt that drift and increase the retraining accuracy of the model. So basically existing papers have high latency, noise robustness also, but not edge deployable. So my goal is just to uh, design a model which can detect the drift also, which are edge deployable also, having low compute complexity and requires low memory. So this is a 3-layer model I am working on, that is a mixed with GhostNet feature extraction, LSTM encoder, anomaly scoring for the sampling, and the XGBoost fault classifier, which classifies the models uh, classify the faults, that is a healthy bearing, inner fault, outer fault, or ball bearing fault. So in feature extraction, I am taking the vibration signals from the bearings, and which converted into images, that STFT, which is having 128 into 64 spectrogram for this feature extraction. And then LSTM autoencoder is used to find out the reconstruction error. And for LSTM autoencoder, we train only on a healthy dataset find out the to find out the reconstruction error, and according to that reconstruction error, we are classifying the images, that is the faulty or healthy bearing fault occurs or not. That threshold is a 0.345 for the reconstruction error. And by using XGBoost fault classifier, I am just classifying the fault, means which fault has been detected, that is the inner race bearing fault, outer race bearing fault, or the ball bearing fault. My model is having only 0.50 MB size for the exhibit fault classifier. So I have used the CMRU benchmark dataset for my project, and in that actually this is the simulation dataset, which is simulation dataset which is developed in one lab by simulating the conditions and artificially creating the drifts, or artificially creating the faults in the bearing, and the dataset is created. That is the 6,000 samples are present in the dataset, and 1,500 per classes, and the dataset is split into 80 into 2, means 80 for training and 20 for testing dataset. And I inserted noise in my datasets and to check the accuracy for my models. So for my processing pipeline firstly segmentation of the samples by means 2048 samples non-overlapping window we have taken, and then we convert that vibration signal into the images, that is STFT, which is having 128 into 64 into 1 tensor dimensions. And then we normalize by removing the for removing that noise, and filtering happen by using the normalization method. And then GhostNet, we use the GhostNet to reshape that images we have get, and now, so here is a detailed architecture. In the stage 1 GhostNet feature extractor, which generates M by 2 primary features maps via standard 3 by 3 row convolution. Means in GhostNet feature extractor, we are using that to extract the taking 1000 sample windows and extracting that features to become our model lighter, so it can be easily deployable on edge devices. In stage 2, we use the LSTM autoencoder, in which we are defining that reconstruction error. So we are setting that tau, that is threshold, that is 0.34, and if that reconstruction error is near to that, means when reconstruction error is low, that means bearing is healthy, and when reconstruction error start increasing, then we are means it high, then we can consider it as a faulty bearing. So we have also set the values for reconstruction error. Suppose reconstruction error is between some window, then it is inner fault. When it shift to the another window, then it is a inner race fault. When it shift to the another window, then it can be outer wear fault. This is the XGBoost multi-class classifier. This is related to the classifier I have used to classify the fault as an inner fault, outer fault, or what type of faults it is. So that is the whole experimental setup I have used this. And for the concept of drift detection, so what is drift means when a machine start detecting that fault, and suddenly after certain times, after 6 months, after 1 year, temperature change, maybe bearing becomes older, and that oil in bearing may be changed, and that's why vibration signals can change. So when new fault occurs, our model is not able to detect the new fault occur, so that is the drift. And when certain time models start predicting the faults, but some different faults that are not predictable by the model because that are different, so that is the drift, and our model detect that drift, and we can and send the drift images to the users, or they just said that drift has been detected, and that images are stored. So after certain time, when we get the images, we can retrain the model by using that images, and our model can again work on the high accuracy by using that drift images. So here in I have used a page Hinckley drift detection. Means in page Hinckley drift detection, what happen when in bearing machines, that means data is machine is working, and at that time just they are always focusing on is there drift detector, is there drift detected. So lambda 50, that is just threshold value they have set for the drift detection. When value increases, that means it suddenly trigger like drift has been came, so that drift can be collected. And drift detection timing is just 8.79 millisecond on the devices. So this is the real-time adaptive monitoring without labeling streaming data. Means suppose we know that there are other drift detection algorithm like Adwin. In Adwin, what happened, that is adaptive windowing. Means we need to select one window and we need to find the drift. Means suppose one window is there, so we need to take data from last window and for the next window, and we comparing that data. So is there any change in both data from last window and next window, then we can say that there is the drift happen. But in page drift detection, they are streaming data, they are working on the streaming data, and by just taking that lambda or threshold value, we can detect that drift is happen or not. So that's why I have choose the page Hinckley test to reduce the memory, because no need to store the last window data or next window data in this algorithm. So
Excuse
for my
me.
model,
This is a
this
gentle reminder that the presentation time is up. You may conclude in a minute or two.
Okay, okay. So my model has accuracy that is for 98.7 accuracy. And here I have mentioned that reconstruction year, means this green is the healthy bearing fault, and other is according to their reconstruction error. We can divide the fault as inner race fault, outer, or ball. And this is edge deployment. I have deployed that model on edge and cloud. So take the difference. Means why edge deployment is necessary: to reduce the latency from 128 0.37 millisecond to just 3.77 millisecond. Means inference latency ratio will be 30x time faster when we deploy it on edge devices, and the model size you can check is also very low, that is 0.50 MB for my this. That is accuracy is 98.67 as compared to other models, and parameters are also more 3.90, and model size is reducing, that is 0.50 MB for my model. So this model is very lightweight and can be easily deployable on edge devices like Jetson Nano. You can deploy on anywhere. So GhostNet LSTM delivers 98.67 accuracy on CMRU across four bearing health state. As we know that four fault class we are just mentioning, and that model size is just 0.50 MB, so it's very smaller and lightweight, so you can easily deploy it anywhere on edge devices, which is having high accuracy. So in which means page include drift detection also. In very fast drift can be detected, like in 8.79 millisecond drift can be detected on streaming dataset. uh, and also it confirms the suitability for the industrial 4.0 ARM Cortex and FPGA environment, and means any on edge devices. It's not needed to send the data to the cloud and then predict the dataset. You can directly predict the fault on the edge without involving the cloud. So this is the just means I have combined 2 3 models, that GhostNet only, LSTM only, GhostNet plus XGBase. These three models are showing different accuracy, but when I come means I mix all that and make a supervised plus unsupervised model, so it shows up to 99% accuracy. So in the future work I have only just work on one data set, so we can work on different data sets and test it, and also we can test on real industrial data. I have just work on public data set, and we can also multi-sensor fusion can be used, means this is not only for bearing data set, but we can use it for different industrial application, to just reduce the downtime of the and downtime, and industrial applications make it earlier response whenever it is needed, and to avoid the loss, and means PDM means predictive maintenance system, we can use it in here, and this is the references I have gone through. So thank you. Hello.
Ma'am, if you have any questions for the author.
Nice presentation. Have you considered what type of bearing means like that?
Means bearing means that motor bearing, which is having that like small balls inside the
Yes, yes,
bearing.
understood. The application, for which application that bearing are used, or have you considered all type of applications?
Yes, I'm considering all type of application, because as a student, I am not able to go in the industry and get the data for specific application. That's why I generalize data set and generalize application.
Means for mechanical industry again it will be
Yeah,
used
yeah.
like this. Have you visited, or just you are not visited that?
No, I'm not visited any industry.
Okay, thank you.
Thank you.
Thank you for the presentation. The next presenter I would like to call is Olivia Yosa for the paper title Empowering the Next Generation, Integrating Multilingual Customer Service Skills into Workforce Development Programs for Hospitality Management Students.
Good morning.
You can start your
Good
screen sharing.
morning.
Is my presentation visible?
Yes, it's visible.
Visible, visible.
Okay, so good morning, everyone. Good morning, Doc. The study entitled Empowering the Next Generation, Integrating Multilingual Customer Service Skills in Workforce Development Programs for Hospitality Management. Okay, for a while. So for the abstract, the study examines the integration of multilingual customer services skills into workforce development programs for hospitality management students. Um, Using a quantitative approach, the study gathered data from 100 hospitality students to assess their communication skills, performance, and confidence in multilingual settings. The findings reveal that most students already possess basic multilingual abilities, particularly in English and Filipino, which serve as strong foundation for further development. So the results also show that the current curriculum includes elements of multilingual training, contributing to students' overall competence. However, while students demonstrate satisfactory performance and confidence, there is still a need for increased practical exposure and strengthened training programs. So overall, integrating multilingual customer service skills significantly supports the development of hospitality students, preparing them for the demands of a culturally diverse workforce and improving their competitiveness in the global hospitality industry. So for this, the researchers would like to solve an answer for the following questions. So for the number one, to what extent are multilingual customer service competencies included in the hospitality management workforce development curriculum? For the second one, what is the level of multilingual proficiency such as speaking, listening, and comprehension among hospitality management students enrolled in the workforce development programs? For number three, how many hours of formal training are allocated to multilingual customer service skills and hospitality management programs? And for number four, what scores do hospitality management students obtain on a standardized assessments of multilingual customer service skills? And for the last one is, what proportion of hospitality management students meet predefined multilingual customer service benchmarks aligned with hospitality industry standards? For the research methodology, this study used or employ a quantitative research approach to examine the effectiveness of integrating multilingual customer service skills into workforce development programs for hospitality management students. The quantitative approach is appropriate for this study because it focuses on collecting numerical data and analyzing it using statistical methods to determine measurable outcomes. The participants of this study is consists of 100 hospitality management students enrolled in a selected higher education institution. They are chosen because they are directly relevant to the study, which focuses on the developing customer service skills within the hospitality field. For the data collection methods, the researchers use a survey questionnaire, a structured survey questionnaire with a 4-point Likert scale, and a performance rating. For the data analysis, the researchers use the frequency and percentage to summarize the responses of the students in the survey, the mean, to determine the overall level of students' communication skills, customer service, ability, and confidence. And for the procedure on how the data is collected, number one, the researchers select the participants, of course, hospitality management students, then give training to the experimental group, collect the data using a survey and performance rating, and then record the results for analysis. For the distribution, table number one shows the distribution of respondents according to age. So table number one data shows that most respondents belong to the 18 and 22 years of age. And then, meanwhile, only a few respondents fall within the older age brackets with 12% age 28 to 32, 4% age 33 to 37, and 2% age 38 to 42. So overall, The distribution reflects that the study is the largely composed of a younger students. Then table number 2, 1.2, the profile of the respondents according to sex. So the distribution of respondents according to sex shows the female make up the majority while males account for 44%. A small percentage of respondents, which is 2%, preferred not to disclose their sex. So this indicates a higher representation of female students in the study, although both male and female participants are well represented. Per table 1.3, the distribution of respondents according to year level. So it shows that the second year students at 28% got the highest percentage. And then the third year and the fourth year students account for 24% and 22% respectively. So this indicates that participants from different stages of their academic journey are fairly included in the study, allowing for a more comprehensive view of students' experiences and perspectives across year levels. 1.4, the distribution of respondents according to the type of hospitality management program. So 56% get the highest score, which is the bachelor's degree, and certificate program, and then 4% falls under or the other program falls under the other program type. So overall, the data suggests that the degree level students make up the largest group in the study, while still maintaining representation from various educational tracks. Table 1.5, the distribution of respondents based on prior hospitality industry experiences shows that the largest group is 38%. Okay, so has no prior experience. And then the less is only 14% reported having more than 2 years of experience. So overall, the data highlighted that while some students have gained initial industry exposure, the majority still have limited hands-on experience in hospitality setting. Table 1.6, the distribution of respondents based on the primary language spoken at home shows that the majority, 58%, use Filipino or Tagalog language. And then, Ilocano got 6% and Kapampangan 4%, Bisaya 10%, and other languages 4%. So overall, the findings reflect the linguistic diversity of the respondents while still highlighting Filipino as the most used language in daily home communication. Table 1.7, other languages known by respondents. So the data shows that a large majority of the respondents are familiar with English with 82%. Followed, of course, by the Filipino or Tagalog at 76%. Okay. For other languages such as Spanish, Mandarin, Chinese, Japanese, and language that get the lowest score is the Korean. While only a few are familiar with languages like Arabic, French, German, Thai, and Vietnamese. So overall, the results highlight that although students mainly rely on English and Filipino, several of them are also developing competencies in other international languages, which can be beneficial in the hospitality industry. Table 2.0, inclusion of multilingual customer service competencies in the curriculum statement. Okay. The results indicate that the respondents strongly agree that multilingual customer service competencies are very well integrated in the hospitality management curriculum, as reflected in the high overall mean of 3.37 per 3.37. So overall, the findings suggest that the curriculum effectively incorporates multilingual competencies and actively supports the development of students' communication skills in diverse service settings. So for 3.0, the level of multilingual proficiency of students, the results indicate that students demonstrate also a high level of multilingual proficiency, as reflected in the overall mean score of 3.18. Okay. Overall, the finding shows that students possess strong foundational multilingual skills that support effective communication in diverse service situations. The 4.0 allocation of formal training hours, the result indicate the respondents generally agree that the program provides sufficient time for multilingual customer service training, as shown by the overall mean of 2.93. So overall, the findings suggest that although training hours are considered satisfactory, there remains a need for enhancement to better strengthen students' practical exposure and readiness. For 5.0, performance and standardized multilingual assessment, the results indicates that students generally agree the standardized assessment effectively measure their multilingual customer service skills as reflected in the overall mean of 3.14. So overall, the findings imply that assessment methods are effective but could be further enhanced to better mirror real-world hospitality interaction. 6.0, Table 6.0, the attainment of industry-aligned multilingual benchmarks. The results indicates that students generally agree that they have attained industry-aligned multilingual benchmarks as reflected in the overall mean of 3.22. So overall, the findings imply that students feel adequately prepared to meet industry standards, although continuous development may still be beneficial for further strengthening their skills.
Excuse me,
So
ma'am.
yes, po.
This is just a gentle reminder that the presentation time is up. You may conclude in a minute or two.
Okay, so for the conclusion, based on the findings, multilingual customer service skills play an important role in preparing hospitality management students for the real-world exposure. So this suggests that although the foundation is already there, further improvement is necessary to ensure that students are fully ready to handle the challenges of a diverse and global hospitality environment. In general, the integration of multilingual training and hospitality education is beneficial, but it becomes more effective when combined with continuous practice and real life experience. For the recommendation, given the results of the study, several practical steps can be considered to further improve student preparation. So I enumerated the recommendation. So it would be helpful for programs to align their languages offerings, prepare students for future employment opportunities. Lastly, for future studies may investigate other factors that affect communication skill, such as confidence exposure or teaching methods, and may be included in a larger group of participants for a broader perspective. So that's all for my presentation. References is already included in the manuscript. Thank you.
Thank you, madam. Chirag, you can have next participant.
Okay. Thank you for the
Thank you.
presentation. I would
Thank
like to
you.
call I would like to call the next author, Ashlesha Bajpai, for the paper title Enhancing Minority, Clash Detection ECG Arrhythmia Classification, a reliability-oriented machine learning approach.
Could you please approve the
Yes, I've
sharing
allowed
my
it.
page?
You can share it again. I've allowed it.
Okay. Is it visible?
Not right now.
Not visible.
It was not visible to you.
Second, please. Now?
Yeah, it's visible.
Greetings, everyone. I am Ashlesha Sri Bajpai, a student in Kalinga Institute of Industry. Hello?
Yes, you are audible.
Okay. A student in Kalinga Institute of Industrial Technology, India, currently pursuing BTech in Computer Science and Engineering. And today, I'll be presenting a research work titled Enhancing Minority Class Detection in ECG Arrhythmia Classification, a reliability-oriented machine learning approach. This study focuses on improving the detection of underrepresented arrhythmia classes in ECG data using imbalance-aware machine learning techniques. It says the host has stopped the screen sharing.
Mm. 1 second, I'll check.
Is it visible?
Yeah, it's visible.
Okay. So many of you might not know what ECG or arrhythmia is, or why its detection is important. So, electrogram or ECG is a graphical representation of the heart's electrical activity. It helps in identifying arrhythmias, which are abnormal heart rhythms that may indicate serious cardiac conditions. With the increasing availability of healthcare data, machine learning has emerged as a promising approach for automated ECG classifications. However, accurate detection of rare arrhythmia classes remains a significant challenge. As shown in the class distribution, the ECG data set is highly imbalanced. The normal heartbeats percentage includes 82.77%, and the rest are very imbalanced. The majority of samples belong to normal heartbeat classes, while several arrhythmia classes are significantly underrepresented. Due to this imbalance, machine learning model tends to favor majority classes, resulting in poor detection of minority class arrhythmias. Since these minority classes are often clinically important, improving their detection is essential for building reliable diagnostic systems. The dataset that we used for this study is ECG heartbeat categorization dataset that is derived from MIT BIS arrhythmia database, which is one of the most widely used benchmark dataset for ECG classification research. The dataset consists 87,554 training heartbeat samples. Each heartbeat is represented by 187 ECG signal features and classified into one of the 5 heartbeat categories. Normal plus 4 different arrhythmia types. And 21,892 test samples were used. Its highly imbalanced nature makes it suitable for evaluating imbalance handling techniques. The objective of this research were, first, to investigate the impact of class imbalance on ECG arrhythmia classification. Second, to develop a baseline logistic regression model. Third, to improve minority class detection using SMOT-based oversampling. Fourth, to implement class-weighted logistic regression as an algorithm-level balancing technique. And finally, to compare the effectiveness of these approaches using standard performance evaluation metrics. The overall methodology followed in this study is shown here. The dataset was first divided into training and test sets. A baseline logistic regression model was trained using the original imbalanced dataset. To address class imbalance, SMOT was applied to the training data to generate synthetic minority class samples. And in addition, a class-weighted logistic regression model was developed by assigning higher importance to minority classes. Finally, all the models were evaluated and compared using accuracy, precision, recall, F1 score, and confusion matrix analysis. Here's a brief description how we handled the class imbalance. In this study, 2 imbalance handling techniques were explored. The first technique is SMOT, which generates synthetic samples for minority classes and helps create a more balanced training dataset. The second technique is class weighing, where higher penalties are assigned to errors involving minority classes. While SMOT addresses imbalance at the data level, the class weighing addresses it at the algorithm level. So there are no changes in the SMOT, and there are changes in the class weighing during the algorithm procedure.
Here is the model comparison. We compared 3 different classification models. The first was baseline logistic regression, trained on the original imbalance dataset without any imbalance handling techniques. The second model was smart logistic regression, where the training data was balanced using synthetic minority samples. The third model was weighted logistic regression, which incorporated class weights to improve minority class learning. This comparison allows us to evaluate the effectiveness of different approaches for handling class imbalance. Here is the result and performance comparison. The baseline model provided a benchmark performance but showed limitation in minority class detection. The SMART-based model improved performance by balancing the training data and increasing minority class representation. Among all the approaches that we used, the weighted logistic regression model achieved the most balanced performance across evaluation metrics, demonstrating better reliability for imbalanced ECG classification. Here is the confusion matrix comparison. The baseline model shows a higher number of misclassification for minority classes. After applying SMART, minority class recognition improved due to better class representation during the training. And the weighted logistic regression model demonstrated the most balanced classification behavior, reducing minority class errors while maintaining strong overall performance. These observations support the result obtained from the evaluation metrics that we saw earlier. The key findings of our research are: class imbalance has a significant impact on ECG arrhythmia classification performance. Accuracy alone is not sufficient for evaluating models on imbalanced medical data sets. Both SMART and class weighted improved minority class detection compared to the baseline model. Among the evaluated approach, weighted logistic regression provided the most reliable and balanced classification performance. For the future scope, more advanced machine learning and deep learning models such as random forests, CNNs, and LSTMs can be explored. The proposed approach can also be validated on larger and more diverse ECG dataset. In addition, real-time deployment in clinical monitoring and decision support system can be investigated. And we can also develop a system capable of continuous ECG analysis from wearable devices that could support remote patient monitoring, and it could reduce the dependencies. Thank you. In conclusion, this study demonstrated the importance of addressing class imbalance in ECG arrhythmia classification. The use of SMART and class-weighted logistic regression improved minority class detection and enhanced the reliability of classification performance. Thank you for your attention. I would be happy to answer any question.
Ma'am, do you have any questions for the author?
Okay. Can you go to the first slide? 1 second. You have collected a live data set, or you have...
No, ma'am,
Okay.
it's a public data set that was available.
Okay. And result, how much percentage you are achieved?
Ma'am, we have achieved in accuracy, we have achieved 99%, but accuracy alone is not important. In medical cases, recall and F1 score are more important.
Yes.
So, I can show in different. Yes, here is the comparison. In baseline model, the recall was below a little close to 0.5%, and in class weighted it increased directly to approximate 0.8%. Yes, and in SMART it increases to 0.8. And talking about the macro F1 score, on the baseline model, it was nearly 0.7, but in classifying and SMART, it reduced to 0.3 and 0.3 in both the cases, because it is
Yes.
the harmonic mean of accuracy and precision.
Just I want to ask whether have you validated your result, because this is a medical, na? So
Yes, ma'am.
validated your result with the doctors or
No, ma'am, it is not yet clinically
yes, yes, yes.
validated.
It should be validated. So whatever may be the result you have, it should be certified or by the doctors, and then it can be, you can
Yes,
say that.
ma'am. Clinical
Okay, so
validation is very
yes,
important.
yes, yes. That will be my suggestion from my side.
Yes,
Okay.
ma'am.
Yes. Thank you,
Oh,
Ashleisha.
Thank you, ma'am.
Yes.
Thank you for the presentation. I would like to call the next presenter, Windy Parmato, for the paper title Towards Smart SME Governance, Developing an AI-based Digital Audit Maturity Framework integrated with internal control systems for SDG 9.
Thank you.
You may start your screen.
Okay, thank you. Wait. Can you see?
Yet now his screen is not visible.
Yeah, now
Yes.
it's
Okay. Good afternoon, everyone. My name is Winnie Permatasyono, and today I'm honored to present my research entitled Towards Smart SME Governance, Developing an AI-based Digital Audit Maturity Framework integrated with internal control system for SDG 9. The study developed an AI-based digital audit maturity framework integrated with internal control system for to support smart SMA governance and SDG in the era of digital transformation. Okay. And the next introduction, digital transformation is reshaping auditing through AI, big data, cloud counting, and automatic the audit tools. This technology improve efficiency, transparency, accountability, and decision making quality. And then for SMS digital auditing in increasingly important to strengthen to support good governance and achieve to SDGs 9, industry, innovation, and infrastructure. AI-based auditing enables automated transaction analysis, fraud detection, predictive risk assessment, and continuous auditing, helping SMS become more innovative, resilient, and sustainable in the digital era. And then, sorry. Despite the growing adoption of digital technologies, many SMEs still face several challenges in implementing digital auditing. These include weak internal control system, limited technological infrastructure, low digital literacy, and limited audit readiness. In addition, there is an important research gap in the existing literature. Most previous studies focus on large organizations, while research on AI-based digital audit maturity in SME remains limited. Furthermore, internal control system and smart governance perspective are rarely integrated into a single framework. Therefore, the study aims to develop an integrated framework that combines AI-based digital audit maturity and internal control system to support a smart SME governance and ultimately contribute to the achievement of SDGs 9, particularly in promoting innovation, sustainable industrialization, and resilient digital infrastructure. Okay, and then in the research methodology, the studies employs a systematic literature review or SLR to develop an AI-based digital audit maturity framework for smart SMA governance. The review followed the PRISMA guidelines to ensure a systematic and transparent literature selection process. Relevant study were collected from Scopus, Web of Science, Google Scholar, and Science Direct, and covering publication from 2020 until 2026. The literature starts focus on 6 key topics: AI auditing, digital audit maturity, internal control system, smart governance, SMA, and SDGs 9. The selected studies were analyzed using thematic analysis and a concept-centric approach to identify key concept and relationship. From this process, four core dimensions were identified: AI-based audit capability, digital audit maturity, internal control system, and smart SMA governance. Based on this finding, the study proposed an AI-based digital audit maturity framework and five maturity level to support smart SMA governance and the achievement of SDGs 9. And then result and discussion. This slide presents the result of the systematic literature review. Using the Prisma approach, we identify and analyze 50 studies published between 2020 and 2026 from Scopus, Web of Science, Science Direct, and Google Scholar. The funding the findings show that AI technologies such as machine learning, robotic process automation, predictive analytics, and anomaly detection significantly improve audit effectiveness, fraud detection, and transparency and governance quality. The review literature was classified into six major themes. The most frequently discussed themes are AI in auditing with uh, 14 articles and digital audit maturity with 11 articles. Other important themes include internal control system, smart governance, SMA digital transformation, SDGs 9, which together form the foundation of the proposed framework to smart SMA governance. And the next, one of the main contribution of this study is the development of five-level digital audit maturity models for SMS. At the level one, manual governance, organizations still rely on paper-based process and manual reporting, resulting in limited transparency and monitoring capability. At the level two, basic digitalization, begin adopting accounting software and digital documentation, which improve operational efficiency. At level 3, integrated with digital control. Digital systems are integrated with internal control mechanism and structure audit procedure, leading to stronger governance and compliance. At level 4, predictive audit analytic organization utilize predictive analytic, automatic monitoring, and continuous auditing technology to support proactive risk management and real-time decision making. Finally, at the level 5, AI-driven smart governance, SMS achieve full integrated AI-based governance with intelligent auditing and automated analytics, resulting in adaptive, data-driven, and sustainable governance. Overall, the maturity model illustrates how SMS can progressively move from traditional governance practice toward AI-driven smart governance that support long-term sustainability and SDGs 9. Okay, this slide presents the proposed AI-based digital audit maturity framework for smart SMA governance. The framework starts with five key input factor: AI capability, IT infrastructure, auditor competence, digital literacy, and organizational readiness. This factor drive digital transformation process through audit automation, predictive analytics, continuous auditing, intelligence monitoring, and real-time support reporting. As SMS adopt this technology, they progress through five levels of digital audit maturity from manual governance to AI-driven smart governance. This transformation is supported by SPIP-based internal control system, which ensure effective risk management, compliance, monitoring, and accountability. Ultimately, the integration of digital audit maturity and internal control strengthens smart SMA governance and contribute to SDGs 9 through innovation, resilient digital infrastructure, and sustainable industrial information. And then the study both theoretical and practical implication ya. From theoretical perspective, it extends the digital audit maturity literature by focusing on SMS and integrated AI, internal control system, smart governance, and sustainability into an unified framework. And then, from a practical perspective, the framework can help SMA access their digital readiness, improve governance practice, strengthen risk management, and enhance transparency, accountability, and sustainable innovation. Finally, Fuso Research is encouraged to empirically validate the framework using quantitative methods such as SAM or PLSM, as well as qualitative or mixed method approach, and to test its applicability across different SMA sectors and countries. And then conclusion. The study developed an AI-based digital audit maturity framework integrated with internal control system to support SMA governance SSDGs 9. The finding identity for key dimension AI-based audit capability, digital audit maturity, internal control system, and smart SMA governance, which are represented through 5-level maturity model from manual governance to AI-driven smart governance. The study highlight that AI capability in IT infrastructure, auditor competence, digital literacy, and organizational readiness are essential drivers of digital transformation. Overall, the framework provides practical guidance for SMA and support innovation, transparency, accountability, and sustainable development. While future research is needed to empirically validate the framework. And then the last slide. The study has several limitations. First, the proposed framework is conceptual, has not yet been empirically tested. Second, the findings are based on literature review and might not fully represent all SMA contexts. In addition, factors such as organizational culture, leadership, and employee readiness were not included in the framework. For future research, the framework can be validated using SMA or PLSM, complemented by qualitative or mixed method approach. Future study may also incorporate factors such as cybersecurity, awareness, and digital ethics, and examine the framework across different industries, countries, and emerging AI technology. Thank you for your attention. That concludes my presentation. I would be happy. Okay, thank you. Thank you for your attention. That concludes my presentation. Okay.
Okay. Thank you and nice presentation. Topic is also
thank you.
nice. Thank you.
Thank you for the presentation. The next presenter I would like to call is Milind for the paper title Zephyr, an AI-driven tool for post-meeting productivity and actionable intelligence.
Yes, sir.
Yeah. Sir, you may start the screen sharing.
Yes. Hello.
Yes, sir.
Yes, sir.
Yeah, I shared screen. Just a minute.
Yes, sir. It was visible.
It is visible.
Yes, sir.
Wait. So now just tell me. Yes.
Yes, now visible.
Yeah. Okay. So good afternoon, everyone. My name is Milind Nemade, and today, on behalf of my students from KJ Somaiya Institute of Technology, I am here to present my topic, Zephyr, an AI tool for post-meeting productivity and actionable intelligence. So basically, we are here to discuss the critical challenge in the modern corporate world, solving the multilingual meeting gap using novel two-tier AI analytic frameworks. Well, basically, we live in a globalized business environment where meetings are the absolute core of academic and corporate communication. However, activity leak. happening would have worked beautifully in a controlled environment if hit the real world. Instant, rapid code switching where speakers shift seamlessly between Hindi and English. This code switching chaos leads to complete breakdown of speaker context, a loss of technical nuances, and ultimately transcription failure. So here is basically the software requirement shown on this slide for the architecture which I proposed. So this basically include backend and APIs, database and storage, AI and ML models, information, communication, and validation tools. Safer organizes this chaos using structured three-pillar architecture, where pillar one is basically a multilingual speech recognition engine powered by Sarvam AI. So this Sarvam AI is a Indian AI company focused on Indian languages and region-specific use cases. Pillar two is a two-tier speaker identification system combining TDNN, neural acoustic with LLM contextual reasoning. Pillar three is Gen AI pipeline perform contextual text extraction using Llama 3.3 generative AI. By operating asynchronously, Zephyr eliminates the needs for platform-specific metadata. This is basically the architecture and technical deep dive. Let's look under the hood at the architecture. Zephyr is built to be a scalable, distributed, and asynchronous in nature. It begins at the client and API layer where we require no platform metadata, just a raw media. Jobs are enqueued via Redis stream and processed by specialized worker nodes. These nodes utilize a heavy-duty stack, including TDNN for acoustic, Sarvam AI for transcription, and Grok Llama 3.3 for reasoning, before storing the final intelligence in MongoDB and Cloudinary. Well, the secret sauce of this Zephyr is how we handle the speaker diarization. And the old way relies on acoustic data alone, which is mathematically insufficient. When human gets messy, think of interruption, crosstalk, or people sharing a single microphone. The Zephyr approaches using a hybrid pipeline. We use node 1 on the initial audio match and node 2 for the context match to fill the acoustic gaps and deliver a perfectly labeled transcript. Well, breaking down that two-tier system, tier one is acoustic embedding. And here it shows like how it works. Tier two is contextual interference. When the sound alone isn't enough, Llama 3.3 takes over the read the room like human would. It looks for direct addresses, self-introductions, like hello, I'm Khush, and uses process elimination based on who has already been identified in the conversation to map the speech to the correct person. Flawless code switching via Sarvam AI. To solve the language barrier, we integrated Sarvam AI, Saras version 3. This engine is specifically turned for Indic domains and outperform the generalized model by handling rapid semantic shifts. It ensures that sentence like we are going to talk about our Naya architecture is captured flawlessly without the hallucinatory errors common in Western trained models. This is the performance benchmarking for this framework, which we have proposed. Here the metrics are word error rate, WER, then ROG1, ROG2, and ROG-L. and speaker accuracy of Indian languages. Here, what is observation is that Sarvam AI-based Zephyr model outperform generic models and giving less word error rate and more speaker accuracy. Well, you can see the result which I before displayed. The output is structured, context-aware, and highly accurate. Rapid conversational exchanges that would confuse other systems are resolved into discrete tasks, and Hindi-English technical terms are captured without errors. So now let's come across basically the conclusion and future outlook in next two slides. So ultimately the sum is greater than the part by orchestrating the specialized model, Sarvam for words, TDNN plus LLM for people, Gen AI for actions. We achieve true meeting intelligence. We have moved beyond simple transcription into a world where the AI understand the required action of business meetings. In final conclusion, Safer successfully bridges the multilingual meeting gap, delivering high accuracy analysis where generalized model fail, but we aren't stopping here. Our next frontier includes real-time streaming, pipeline processing, the integration of multimodal inputs like video and spatial audio, and advanced E2E encryption for secure enterprise deployment. So these are the references of the paper which we have used. That's all from my side. Now the session is open for the question and answer.
Sir, nice presentation. Thank you, sir.
Yeah, thank you, ma'am.
Thank you, sir.
Yeah, thank you.
Thank you so much for the presentation. And I would like to call the next author, Suramrit Singh Kohli.
Oh, yes.
Yes. Sir, you can start sharing your screen.
Yeah. Hello. So my project is NanoClear. It's the extraction of microplastics from human blood. So the research question basically addresses how PEG coated, which is polyethylene glycol, and chitosan, which is another layer, coated superparamagnetic iron oxide nanoparticles, which are basically PEG and chitosan coated spions, which can enable the capture and removal of microplastics from human blood using an external magnetic dialysis filtration system. So the problem basically is that 80% of people have 1.6 micrograms of microplastics per ml of their blood. And essentially how they enter is through three main ways: inhalation, ingestion, and dermal contact. Inhalation through multiple, how we tear when we tear wrappers open, there's plastic released into the atmosphere which we inhale, or burning of plastic, which causes microplastics to enter the atmosphere and then enter our body. And since they're really small, they can pass through the system and they can enter the bloodstream. And the moment they enter the bloodstream, that's when the real damage starts to be caused, because they can move around anywhere, and the blood is being constantly filtrated in the body. So there's a kit called Plastic Tox, which can actually detect the average amount of microplastics in a blood sample. And through their research, we actually found out that the symptoms of disease and the problems caused by microplastics in the blood are after this number of 1.6 micrograms, which is average on 80% of people. Once this number becomes 50 micrograms per ml, that's when problems actually starts to be visible and evident. symptoms of microplastics causing damage into your filtration system of the body is visible. And that is essentially because when it enters the bloodstream, the body is constantly trying to clean the blood through the liver and the kidney. What it does is basically it causes liver dysfunction as the liver is constantly trying to clean the blood. However, the liver is not trained to do that, trained to remove microplastics, so there's a very high overload on the liver. Moreover, even the nephron in the kidneys, the glomerulus is not trained to remove the microplastics, so microplastics actually get stuck over here, and they cause the glomerulus to essentially stop working after a certain point, which is what causes chronic kidney disease. And also in the kidneys, after polystyrene microplastic, specifically this one, uh, increases more than 1 micrometer, it leads to insulin resistance and the pancreas stop working, which leads to diabetes. And overall, it causes neurotoxicity, inflammation, and at a cellular level, since it's extremely small, it causes organelle damage, DNA damage, and mitochondrial dysfunction. Yeah. So what I did to remove it is basically I created a system which is an external magnetic dialysis system. So the particles that I use are called spions, which are superparamagnetic iron oxide nanoparticles. I have them here. So these are iron oxide nanoparticles which are extremely magnetic. As you can see over here, I can move it around using a neodymium magnet, and since it's extremely magnetic, it can be attracted by magnets very easily, which is the main property that I'm using to extract microplastics from the blood. Another property that these peons have due to their coating is how they can attract microplastics. They can actually bind with microplastics and engulf them, and since they can engulf them, I can use a magnet to remove them from the body. And how I do this is basically, this is the body with a lot of microplastics in it. Then this is an inlet which allows the blood to exit the body and enter the system where the cleaning actually occurs. And microplastics enter the system where my particles, which are spions, enter from here. Sorry, yeah, they enter from another inlet, and here's where the mixing actually happens. So I have this system with me over here, the actual dialysis system, and as you can see, there are two different inlets. One is for blood, and one is for my particles. So this larger wire is for the blood, larger pipe is for the blood, and this is for the particles to enter, my particles to enter. And this is the mixing point inside this. And the mixing point is actually the most important part, because if the particles don't actually bind with the microplastics, then there will be no removal actually happening. So the mixing point must be slow, must be reducing the velocity of the blood, and the particles must bind to the to the spions. Then, as you can see, these are the magnets which allow the particles to get stuck to the magnets, and then they won't be moving ahead in the system. So basically, the microplastics in the body will be engulfed by the spions. The spions will then be attracted to the magnets, and they will get stuck to the magnets, and then the pure blood will be entering back into the body. So that's how the blood is actually filtered, and microplastics are removed. Then the system can be cleared through just water. After it's done, they can be removed. Then my project was actually divided into 5 main aspects. The first one is the most important part, which was the synthesis of spions, which are superparamagnetic iron oxide nanoparticles. Their size has to be perfect. Their surface has to be perfect, as it has to bind to microplastics, and it has to be extremely safe as it is entering the bloodstream, and has to be extremely efficient, because the ratio of spions, which is my particles, and the microplastics has to be not more than a certain point. As if it's more than 1:1, a lot of spions will be have to put in to remove the microplastic, which is not good for the body again. So the efficiency has to be good. Safety and efficiency is the main 2 aspects for the spions to be created, and consistency of characteristics over a large range. That's why I did 11 trials to actually ensure that the characteristics of each batch is the same, they both are equally efficient, all are equally efficient, equally sized, and the surface is equally safe. Then I tested on synthetic blood, which is basically created through uh, a bunch of proteins, and they basically mimic the internal body environment using electrolytes, and the pH was maintained in the synthetic blood. And I tested it on synthetic blood if the particle is actually able to remove it, if the spions are able to remove the microplastics. And then I did a proof of concept in synthetic blood to test the characteristics and the efficiency of microplastics, where I did 4 trials. And then I did the mechanical test where I actually created the system through multiple iterations, where I actually found out that the particles, what is the particles flow rate, and what is the blood flow rate, and how the framing of the device is actually more efficient, actually can increase the efficiency of the system. And blood integrity test. So my particles had to be proved to be safe in the bloodstream. That's why I did a blood integrity test where I found out that my particles are actually safe in the body. And since it's on real blood, I couldn't do a lot of trials. I did only 2 trials to keep it ethically correct. And yeah.
Excuse me,
So,
sir.
yeah.
Just a reminder that the presentation time is up. You may wind up in a minute or two.
Okay, so this is synthesis, and the two coatings are PEG and chitosan. This is how the particle actually looks. This is the spion. This is the first layer of PEG, which is polyethylene glycol, and this is chitosan. Sorry, the first layer is chitosan, which is positively charged, and microplastics are negatively charged on the surface, so it's efficient. And PEG is biocompatible, so this is the final layer of the coating. And this is the proof of concept test where I actually physically removed it from synthetic blood. And this is the SEM image which actually shows that that the particles actually engulfed the microplastic. And these are the 3 iterations of my uh, of the mechanical testing, and that's how I reached this stage. And the turbidity change in real blood, which actually showed that my particles are safe in blood, as it was the microplastics actually reduced significantly, and which is visible through the turbidity test as it became 0 at the end, the microplastic turbidity index from 250. And the safety, it's comparable to a real dialysis system where there is reduction in cell volume. However, it's not significant, so it's primarily because in the body, when cells move around, when they hit the walls of the veins, there's cell lining which actually absorbs the shock, which doesn't cause damage to the cells. But when the moment it enters a pipe, it causes damage, and as there's no cell lining, so the shocks are not absorbed when the cell hits the walls of the pipe. That's why there is damage, but it's not significant and can be recovered through a 21-day plan. That's why it's safe. And yeah, that's it. Thank you. Any questions?
Hello.
Yeah.
Nice presentation. Have you validated your results?
How do I validate my results? Basically, yeah. So when I go back here, so basically the attraction of microplastic to the spion is actually visible in this SEM image, where my particles are engulfing this microplastic in the proof of concept, and in the actual one, where I used a pseudo. So I didn't have access to Plastic Talks, which is a company which gives you the exact amount of microplastics in your blood. But I don't have that because I'm not a diagnostics company.
Okay.
However, what I did is basically I created a turbidity sensor,
Okay.
which uses optical density and voltage. Basically, use some basic math to find out the average microplastic turbidity index. However, the uncertainty in this case increases by a lot, so there's a 12% margin of error. However, I got an initial value of 250 after adding microplastics, and in the end, it was 0.0 after round
Okay.
1, and in round 2 also it was 0.0. But you can see the difference over here. In analog to digital converter, it gives you the inverse value of the change. Why I
Mm-hmm.
did 2 rounds is basically when you do a normal dialysis
Second
system,
round, huh?
you do multiple rounds, like you do over 3 months, and you don't need to do that in this case unless you again reach a value of 50 micrograms per ml over time exposure.
Mm-hmm.
Yeah.
Okay.
So it
Nice.
was visible through that.
Thank you.
Yeah. Thank you. Any other questions?
No, from my side.
All right. Okay.
I sincerely thank all the authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the virtual conference. We'll be very happy to have you in the next version in 2027. To all the presenters, they would be getting their digital certificates through email within 2 working days. The publications would be live within 7 to 8 months. Kindly cooperate with the team of TIBS 2026. I also thank the session chair, Professor Chaya Jadhav, for their valuable insights. Ma'am, if you could share some words.
Yes, sir. All the presentations were very nice, and it covers most of the different areas. And the work done by all the participants was very nice. So thank you. And this is a very good platform for this to present their research work in this conference. Congratulations to all the participants. And thank you for your start and end of this sessions and everything. Thank
Thank
you.
you so much, ma'am. I would request everyone to kindly switch on their videos to take a quick photo. Thank you so much, everyone. Have a great day.